Hello and welcome back to the development of the Feersum Scheme compiler. So in today's stream we're going to have a look at continuing the implementation for schemes define library support. In the last stream we started to work on recognizing the define library special form. So define library and scheme has various different sub clauses which we're calling library declarations, and the three that we care about recognizing for the time being are export, which makes parts of the library visible outside, import, which brings other library exports from other libraries into this declaration, and begin blocks, which are used to write the body of the library, which is where you define the functions or other parts of the library that you want to export. And the plan here is that we are going to compile each library down to its own C# class. So the structure of that will be similar to the structure that we currently have for our overall script modules, but instead we'd have one per library, and then everything that gets exported would end up being public property, I think. So actually, let's just update this example. So the way that it works at the moment is if we have a class for our test library, we would, I think, be aiming to have a public static object, because everything is object in our compiler. At runtime we do some more type checking, but everything's passed around either as boxed types or instances of reference types. Object, and then the thing is called greet, and we would have something like public and main would then do something like greet equals new func object array object. So what this is saying is that every scheme library would actually, like all of the public things that are exported, in this case greet, would be a field, not a property, just a plain field that's static. When we initialize the library, which should happen only once, we would run whatever the body is, and in this case the body is this define, which binds greet to some anonymous lambda. So this would be that anonymous lambda. So this would actually be like lambda 0, I think, probably. And then we'd probably put this. So scheme method, we put scheme export or something. And we can keep the annotation for what to name the export. So let's go over what we did in the last stream. We define it in our compiler. We have several different stages. So first we parse all of the source into what we call an abstract syntax tree. So that would represent this whole expression as a node that says this is a form, and inside the form there is another form and another form, and so on and so forth. And then the begin would be a form, and inside that, so it's a tree made up of different types of things. So like this is an ident, this is an ident, this would be a constant of type string. This would be a constant of type character. And after we've parsed it, we then bind it. So binding is our name for taking the abstract syntax tree and resolving all of the references to symbols so that we know that, for example, here we know that person is this parameter, and we know that new line is the new line function from scheme base. We defined a set of types to model what our bound representation of a library would be. So we've got this bound library declaration, bound import set, bound export set, and bound rename. So this is all about like exports, imports, and that kind of stuff. The thing is, and then we defined a bunch of methods. Where were they? So we had bind library name, which recognizes something, a form that's like a test greeter or scheme base, which is a list of identifiers that reference a library. So this is a bit like a Java package name or a C# assembly name. So like system.text.json, but instead it would be system.text.json as a list of identifiers. And we also have parse identifier list, bind library declaration, and all the rest of these functions. I'm not too happy with where we ended up, because at the end of the day, the thing that this is producing isn't really a bound representation of something, because all it's really doing is recognizing the form. So there's no extra information that we're resolving when we make like a bound import set or a bound export set. We're just taking the list of identifiers and just, that's it. So I think where we're going to start today is taking inspiration from how we implemented macros. Macros have their own strong types for things like patterns and templates and transformers, which are the things that make up a macro definition. And then we have a parse macro method, parse syntax rules, parse transformers, and we then produce these strongly typed macros, which we can then use at a later date in the compiler. So I think we should do the same thing for libraries. So I'm going to start off by getting a new file. Just that one. Nope. Add file. Don't do this often. Library.fs. Libraries. Because you have macros, so. And this is probably going to want to be after syntax. In F#, the order of the files matters because the compiler treats it effectively as one big long thing, and declarations can only depend on things that were defined before them. So if we want to be able to use the types from syntax for things like the abstract syntax tree, we need to make sure libraries is after it. Then we do module libraries. Let's see, we probably want syntax, diagnostics, and utils, just like the macros. And the entry point is going to be what the binder uses. So let's have a look at how the binder recognizes defined syntax. So it does macros, parse syntax rules, and if that produces a macro, it produces some nominal bound form to represent it in the tree, otherwise it does an error. So we'll do the same kind of thing. So for our define library, ID needs to have an ID and it needs to have the body of syntax rule. So for our library, it has a name and a body. So I think what we will do, I'll just steal the entirety of this for the time being. And we'll have parse. It's going to have a name and a body. It's not happy because there's a whole bunch of other stuff. We don't have bind library name or anything like that, but we could do libraries parse name and body, and we can do a match over that. If we get a library, we'll return, this is where we return some kind of bound library, which would, when we actually emit the IL at a later date, this should be enough information that we can emit the new class declaration and all of the functions for the body. But for the time being, we can go with we'll just do a quote of the something like that. And then if there is an error, we need to emit the diagnostic. Yeah, no, that doesn't take a parameter. We need to do context.diagnostics.add. Just deciding whether or not we actually want to have it be the responsibility of the binder to register the diagnostic, or whether or not we want to build up the diagnostics inside. It could be that we return a list of diagnostics. So we have add, which takes a single. So we could have append. Do we have? We could do for index. For each do. So we loop over every diagnostic and add it. Add a collection or append. So that will then mean that the parser is capable of returning a list of diagnostics instead. I'll just have an empty list or something. It doesn't need, that's just to make the compiler happy for the time being. And then in here, we can get rid of, well, let's go steal the bind library name and the other things from here. So we've got bind library name, which does parse name element. Oh, that's all inside there. We've got parse identifier. Which I think is only used in parsing of libraries. Try parse rename, bind import, bind export. Okay, so now we don't have a context, but we can make a context diagnostics bag, so we can have create an empty one and then pass that in. And then if there... We'll add the diagnostic here. I don't think we need to. I think we can just... I think we can do result.bind with this. So we'll do bind library name. As a result of something and diagnostic. Bind library body. Must still be in the binder somewhere. Starting to wonder whether or not this is taking too much stuff away. I'll have a look. We'll take the types as well. So it's the bound, imports, exports, renames. I'll get rid of a library as bound type for the time being. And then this is going to be... What are we missing? This will be a bound expression library. We... Type. It's going to be string for the name and bound library declaration list body. So this is going to be, this type library definition is going to represents It's not useful represents the body, past body of a define library form. Get rid of that orange. Then this is going to be library definition. .library. Then what's going on here? State node. So now we don't have context. We're just adding straight into this diagnostics bag. And we need some kind of annotation. It's diagnostic bag. Right. Then down here, bind library name. Oh, probably a bit too big. Bind import. Let's just go through and rename all of these parameters and then change anywhere where we're trying to add diagnostics to add it to this diagnostics bag directly. And I think we're going to need some more type annotations as well. Context there. Let's go change that to be a diagnostics bag. That one seems happy just passing the diagnostics on. This one's clearly worked out it's a diagnostics bag, so it's fine. I think the types are all flowing through now. So this takes a diagnostic bag, the bound library name, and a list. What's going on here? Bind library body. Oh, I see. Bind library body is not fallible or infallible even. So that means we don't need to use bind here. We can just do map. Bind library name. And yeah, that wants to be string list. So the library's code at least is happy. What about this? So that hasn't quite worked out whether or not this is an errors list. Parse library declaration. That is saying it is only one diagnostic. So bind library definition. This is going to be awkward. I think every time when we return an error here, well, maybe here. This is really awkward because some of these code paths don't actually return an error result when they fail. So here we just create a warning, add it to the bag and carry on. So we don't necessarily have a good way of returning this list of diagnostics. Unless we have this return a result of pair of string list diagnostic list. So all of the cases where effectively whether or not the bind library name, which let's rename it now, the parse library name, regardless of whether or not this succeeds or fails, it would always return some diagnostics. It's a right mess, isn't it? The whole, we got several different nested functions. We've got these error cases. So what we could do is we could extract some of this. So like diagnostic create, going into result error, and then returning. Let's see that. Well, let's see how far we get. So that is check reserved names. One of the other problems is the errors in this case. It's just a single diagnostic. So we could do with collecting up every single one of them. Starting to wonder how much of this code is worth saving. Now I think we can get this roughly working, but let's just do an add here, and that will at least make everything type check. And we can run the tests and see how broken everything is. Even if it's pretty broken, we can at least stage what we've got. Yep, it doesn't. I'll put a little fix me there as well. Interesting. Only a single error. But it is about missing warnings for bad library names. So that's positive, because it means the only thing that failed was the thing that I thought was going to fail. Let's at least stage what we have. So we have a snapshot, and then we'll rewrite these types to represent the parsed library in the way that we want it to be. And then we can look at rewriting the parsing and see if we can come up with a more ergonomic way of flowing those errors through so that we still end up with warnings. Ooh, I've just had an idea. How about if parse does result.map so then we've ended up with a library definition or diagnostics. What we could do. Right, let's change every single case where we do result.error. So, for example, here, we create a diagnostic. and then we return an error. What we could do instead is we have our diagnostics bag, so we could do diags.emit so that we immediately emit the diagnostic. And then we can just return a unit error. So we're tracking the failure to parse separately from our list of diagnostics. So now parse name element is a result of string unit. And we'll do the same thing down here. We'll do, oh, that's not the right place to put that new line. We'll just emit the diagnostic. Return a unit error. Where was parse identifier called from? Looks like that plan has fallen apart a little bit. So parse identifier list, where's parse identifier list used from? Too many highlights, I can't work out. Oh, I spelled identifier wrong there. That's why I'm not seeing it. So this whole thing takes a diagnostics bag, AST node, string bind import form, bind import form. So ready. Bound import form is already like returning an error and adding the diagnostic, I think, because it's doing parse identifier list or something like that. Parse identifier, which if it got an error, it's adding it to the diagnostics bag and returning an error. So we get there. Parse library name is now returning a unit instead, so we don't need that. Ah, hello. I'm not making a game. I'm making a compiler for the Scheme programming language. Scheme is code that looks like this. So it's got lots of brackets, and it's really old. Anytime I've ever tried to make a game in the past, I've ended up getting distracted and ending up with something half finished. Anytime I've tried to make a compiler in the past, I've ended up with the same. But I'm hoping that streaming will force me to actually write code instead of going off on some kind of tangent. I think this might actually compile. Fingers crossed. Nah. Because what? It has the type unit now. Our unit error stuff has gone a little bit too far. Oh, yes, because now we end up with a result that's either a library definition or a unit. And then the plan was we would do result.map. And then if it was a library, we would turn it into a pair with the library and the diagnostics. So we'll just take the diagnostics to get the inner list of diagnostics, and then result.map error, where we would just ignore whatever the error was because it's just going to be the unit, and return diags.take in that case as well. That's not how you spell diags. And then we end up with OK being library definition or diagnostics list, the error being diagnostics list. Now the binder should complain. So this needs to be diags or library, and then we can do context.diagnostics dot append diags. So these will, in theory, only be warnings. But at least this means that we've managed to parse a library. And this is the list of errors. And then if there was an error, we need to do append there as well. And we can rename this now. This must compile. Good. How about the tests? If the tests pass, then I think we're at the point where we just need to think about naming things. So, premature. Is this... What's gone wrong here? I think this is the same list of errors, but in a different order. How do we fix this? Well, I mean, like, there's nothing actually wrong. We don't care too much which order the diagnostics for our various different errors are emitted. Because people are probably going to like just render them at the point they are in the text or sort them or something like that anyway. So I could just accept the change, but this kind of thing is going to happen in the future as well. So maybe we want to make it so that the spec tests sort the diagnostics. Yeah, let's have a look and see how complex that would be. So it would be in spec tests. In here, we have a bunch of F# that basically uses XUnit theories and member data to run our compiler against everything in this spec folder. So it just globs through for anything that says SCM and compiles it. And if it's not in the error folder, so fail folder, then it tries to run it and then checks that the output and the diagnostics match. So the parse result is all about what does the AST look like. So we've got this diagnostic sanitizer. Is that it? The diag sanitizer is... it sanitizes the diagnostics. Can we just... sort by... location dot well, can we compare locations? I'll try that. So that takes a list of diagnostics and produces a list of diagnostics. Let's do that. Is that better? Yeah. No. You're not happy. Why are you not happy? What about that? No. Also not happy. All has to go on one line. Fair enough. I guess unless we do this, it's probably going to allow us to do this on another line. There you go. I love programming languages that treat white space specially. And compiles. Let's run the tests. This may well cause a lot more failures because we'll have reordered the diagnostics. If it does, the best option might just be to accept them all. Yeah, 5 fails. But that was going to be 314. And then that's now 314. So we've kind of got them in the wrong order. Sort by descending then. Let's see. If this ends up with a lower number of failures. and then whichever one looks like the smallest change, we'll just accept. One. And it's our library names one again. I mean, sure, let's go with it. We've got the library name prefix is reserved, and library names should not contain complex characters, and they are in the same position, but they are the wrong way around. Let's just update the snapshot. Because we've got the right errors, we've got the right warnings. Nice. I mean, it was rewriting the snapshots, so that was the only thing that failed. I shouldn't be surprised that it all worked. Get rid of this update snapshots as well now, because we don't need it. We've got the special VS Code task to do it. The VS Code task. Update snapshots uses the magic power of setting an environment variable. So let's review what we've got so far. The binder. We have got rid of a whole bunch of stuff. We still need to... This in some ways is a regression because we're not actually even including the bound libraries in the tree properly. We're just fudging it with an empty sequence expression here. But we've got fix me for it, so it's all good. Compiler, I've commented out the fact that we used to handle libraries. We've got this new append for diagnostics bags so that we can just add two diagnostics bags together. Libraries, which is the new module. We need to rename all the types in there. So let's do that before we commit. Spec tests now sorts the diagnostics. I mean, we can stage that change together. Sort diagnostics in spec tests. This ensures binding of the library. I am building a scheme in F#. I'm just gonna... Oh, I mean, I'm gonna have a demo. So, got a whole load of test suites here that display like scheme that we can currently support. I think the most interesting one so far is either itafact or tail. So let's go look at tail. This was... Yeah, I mean, it kind of is a Lisp stream. And when I get around to actually running any code, we do have a REPL. So the way this is working is there's an F# compiler, and then we can either run it as a one-shot compiler and it produces an assembly that could be run on .NET 5, or you can run it as a REPL and it'll compile it to an in-memory assembly and run it. I have closures, yes, and I have... So closure conversion, where we lift things into an environment and I'm modeling the environment we have like a support library called Serifa, which has, wait, I'm misremembering things. Now, at compile time, we dynamically generate like an environment object, which is basically just a list of objects, and then captures our indexes into that list. We support tail calls. That was the most recent interesting thing that we did. So the .NET IL has a tail prefix you can put on calls. I'm just using that. I think I've seen some of your streams. I only know Scheme really from back when I was starting at uni. We did Scheme in the first year as like the introduction to programming, with structure and interpretation of computer programming. Computer programs. But I've meddled around with various different programming languages, but yeah, I just felt Scheme, like, technically, because it has static scoping, in theory you can compile an awful lot of it down to .NET. The tricky bit is going to be continuations, so like call CC. I think I'm just going to fudge it the same way that Kawa and similar ones do, by using exceptions to support some of what call CC can do, and then just saying that the rest of it's just not supported, because lifting the stack is going to be awkward. I did have some idea about maybe using .NET tasks, because that would kind of do a lot of what call CC would do, but that would make the bytecode we have to emit really like a whole level more complex than it really needs to be. And because .NET tasks are effectively moving the stack onto the heap, but I don't know if they would support all of what call CC does. The current thing I'm trying to work on is getting support for define library. In the last stream, I worked on like an initial support for it, where so the compiler has several different stages, like parse and then bind and then emit, which we call compile. And I kind of started off implementing it in the binder, but then I've decided that I kind of want to separate out the parsing of what a library declaration is from actually binding all of the identifiers. So binding is like when I would work out if you reference like a specific symbol, which logical. It's called a storage reference. It's probably a bad name. Symbol would be a better name for it. The actual kind of, it's a variable location in memory. I don't know. It's difficult to work out what to call some things sometimes, especially when you've got .NET. So you've got like the .NET name for things. You've got, it's like the F# name for things, and then you've got the scheme name for things. Got on a sidetrack. Anyway, I was naming things, so the hardest part. So all of these things are saying bind and bound and all the rest of that, but I want them to just be plain, like a richer representation. So we've got the abstract syntax tree. So this is more like a concrete syntax tree for libraries. And I do the same kind of two-stage parse and bind for macros as well, because sometimes you want to just separate out the more complex scheme forms, like recognizing what they are and then being able to walk over them like a normal compiler rather than having to deal with it in the abstract of like it being a form and then like having to parse it every single time you want to do anything useful with it. So bound rename is just going to be symbol rename. And I didn't use the right way of renaming. Let's actually symbol rename, symbol rename. So bound export set, I guess, can just be export set. Import set can be import set. That can just be a library. Do we use this error type anymore? Find references. Yeah, we do. I'll leave it for the time being. Let me commit this code and I'll walk you through what macros do at the moment. We support a lot of scheme macros. It's not a properly hygienic macro like support yet. I think I need to wait a little bit for libraries, and because I think libraries are going to affect how symbols work in scopes, and once you have like libraries, because libraries imply namespaces, I think making hygienic macros might become a little bit easier, because libraries kind of force you to treat the fact that, for example, here I've got error, and that is a different error from the one in result error, and it's a different one from the ones in the binder. So that's kind of what you need for macros, where you need to be able to distinguish between the source code that the error symbol came from, where you actually bind it. So refactor parsing of library definitions. Library, parsing of libraries. Yeah. Good one, VS Code. So, macros. We have macros all comes down to this parse syntax rules. So parse syntax rules does something similar to what we've just been seeing with the libraries, where it basically walks down the AST nodes, and eventually you'll end up with something that's an instance of the macro. So the macro type has the name on the list of transformers. So a macro transformer has the pattern and then the template. So I'll find an example of some macros. So you can do things like define syntax foo. So foo would be the macro name, and then these are the syntax rules. So this is the pattern, and then this is the template. So once we've passed that into our macro, we store the macro when we bind. We store the macro on our binder. And then when someone references the macro in the future, we expand it. So that would be in the apply. Yeah, we also have let syntax support for the same thing. So I think it is bind apply, bind application. So what we do is if you're referencing an identifier and the identifier is bound to a macro symbol, then we call macro apply. Macro apply is back in here. So macro apply basically does this macro try apply for each one of the patterns. So that's basically seeing whether or not the pattern matches. If the pattern does, then it expands it. And then if we run out of transformers to apply, we return an error. And we then actually turn that back into a diagnostic. So at compile time, if you referenced a macro that can't be applied, you actually get a compile time error for it. I don't know if that's a good or a bad thing, but it's definitely a thing. I think that's correct in terms of scheme. Like if you're referencing a macro and it could never apply, the program shouldn't work. But the problem that we do have with this is that because we're just basically taking the template, let's see, do we have an example? Macro, which, no. I'll try and run the REPL, see what I can do in there. The problem we have is that your macro could define a symbol like foo, and then you could also reference the same thing in something that you pass in that ends up being expanded, and you end up with a collision. Let's see. You could do something like let syntax foo, which is our macro name, syntax rules with no special identifiers. If you say foo and then a, then we turn that into maybe. Trying to think of how you'd be able to show this bug. I remember we got it from, actually let's stop trying to do it that way. In the built-ins, we have a bunch of macros that are compiled into the assembly themselves. So we had the problem with the OR macro. So for things like AND, we're just rearranging the syntax tree basically. But for OR, we need to store the value of the test because we would need to return this value. So and we can only evaluate it once because test one could be like a function call and we don't want to end up calling the function twice. So the way I've done it here is I've just generated an identifier that is a GUID, and proper hygienic macros would kind of do that for you. So if I'd have written like let x test one and then x and x here, hygiene would have meant that any x that you'd written wouldn't collide with the one in the macro. But that's the only thing I think that we don't properly support yet in the macros. So back onto libraries. Let's check off that to do. We have separated it. So we now have our library, and we need to do something to bind it. So let's just shell out to bind library. It's going to need the context, and then that's it. No. How about we implement it? Here seems good as enough. What are you upset about? I mean, it does contain append because we wrote it there a minute ago and you just compiled. No. Oh, damn it. I mean, I think it just compiled. I don't know why it's complaining about this. It might need to be turned off and on again. I know it can get confused. So bind library. What do we actually want to do? How do we want to represent a library? So things like imports and exports. So if I do things like export greet, import scheme base, they just control what is either pulled into the library's scope or exported from it. They don't actually control what we need to emit into the class that we generate. But bound syntax tree, which is what represents effectively the contents of a compilation unit. That might come in useful. It could be that the body of a library is actually a bound syntax tree. Or it could just be a list of bound expression. Because you could have more than one begin block. And each begin would basically just be a seek of bound expressions. Let's start off with just bound expression list. I think we're probably going to find that we want the library name as well, so that we know which class to put it into. Which might... Well, do just the bound expression list, and then when we get to the emit and can't do anything, we'll come back and update that. So this wants to be, well, let library context equals find a context I guess it's kind of like a global scope. Maybe. Let's see. Let globals start off from that. Yes. I'm trying to think where else we use the blind create from global scope, because I think we might end up kind of fudging something somewhere to end up with. Okay, so when you call bind, bind in context. Does a library import? Does it capture the outer context? I don't know. Whenever we call bind, we could pass in a scope. So if someone had put something in the root scope, I mean, let's just create root scope, which is, I think, yeah, all of the built-ins and all of the macros. I think we would have. Let's start off with an empty scope and see how far we can get. I think what we'd probably want to do is loop through all of the library's import declarations and turn them into entries in the global scope, and then do a bind. Bodies. So the bound bodies would be library dot. What is the library? The library is. Let's just add a type annotation. Definition. This might be easier if it was a struct rather than an enum like this. Maybe. Oh yes, of course. That's going to have broken some things, but hopefully not too much. Library definition. So we just need to do library name. Declarations. Bound body. And that needs to be an equals. Does it? Yeah. Should rename some of this. So parse library body does parse library declaration parser, and then parsed bodies is body and list map parser. Parse import forms, parse rename. Doing bind anywhere else. Bind export. So that needs to be parse export declaration. Try parse rename. Good. Only 2 references left. What's this red squiggles? Oh, this needs to be parse library definition. That's what's gone wrong. So parsing library definition parses the name, parses the body, which parses the declarations. And then the binder is going to need to be updated so that we parse the library definition. Which is going to be down here. So we have the library definitions, declarations, definitions. Have I misnamed that? Parse library declaration. Yeah, declarations. List dot. Well, do you want to do this as a list or just want to do seek dot? So we want to take seek where the libraries dot. Let's go. I might actually want to just open the whole libraries. This is getting awkward, especially since I can't type libraries very well. Declaration. Begin. If it is a begin, return true. Otherwise, return false. Might be easy to just do this in one thing. So you could do seek dot. All iter. Yeah. Where's the one that takes an action? But we wanted the bound bodies. Do we have? Way of so map 2 does pairs. Fold. I'm trying to think of the function where you can return an option. State, the initial state. Oh, that keeps going until it returns none. Um, is it map fold state? T result state. Returns results. Is it a flat map? We don't have it. just do seek.filter and then seek.iter. Then we could do list of seek at the end. Oh, so we could do the seek.map. So this is a declaration. So you match D, and if it is libraries.library declaration dots, and we need to add a new one for begin. Then we return true, otherwise we return false. Then we map that. Let's go add the new type in here. So this one wants to be, so we've got a begin and a body, which is just a list of AST nodes. So I think we just want to do library declaration dot body of begin with body. Then up here we'll make the begin be of AST node list. So we're not actually parsing it in any way, we're just passing it straight through so that the binder can use it. And then the binder will get if we're mapping to the unit, you're right, we could just ignore it, but we don't really want to be mapping to unit. What I really want to be doing is how about take the declarations, map them, and then do option collect. Have I done this one yet? No. So we have utils. Let's go deal with that. So we have now collect is not a takes a sequence and it returns a list. It does this by let collect uses an accumulator, and that's going to do match sequence with, and then if it's the empty list, so run out, we return the accumulator and we'll do collect sequence and the empty list. Then we need to do if there is a head and a res. So we would do something to I wanted to make this tail recursive. How is this going to work? Are we going to end up with... Are we going to end up with everything in the wrong order? So match head. If there is some value, if there isn't, we want to return rest with the accumulator. Otherwise, we want to these are going to come out the wrong way around, so you might as well do this. Yeah, you need to be recursive. So it's not tail recursive, which is unfortunate. See. There's got to be a way of doing this in a nicer way. Just can't remember what it is. So pick's just taking, I assume, the first thing, which returns true. Reduce is like compressing it down. Maybe this is what we want. Seek.scan back. I think it is. So we do sequence. So if we get a value, then we return that. Otherwise, we just return the state. That takes the folder, the source, and the state. Let's just do that instead. There's no need to do so much pipelining. What are you unhappy about? Space to have type list B. Let's just check. Let is unfinished. Okay. think we just want to do list scan back. Just return an error for the time being. So where does this want to take? Scan back. I have to take T state, and then we take a list, and then we take the state. So this will be our function, which takes body and state. And it always returns state. But if it is a begin block, we can do something. Bind in context, which takes the context and a node. So this is going to be library context. The node is block. And then we return bound expression. Oh, we just return bound begin, paste it onto state, whatever state is. Match body. This then needs library.declarations and an empty list. Then bound body should hopefully, it's a list of object. Why? Oh, because this is taking a pair, and it should instead be taking two parameters. Block. Because why is that a list of AST nodes? We can just stick a sequence on it, I guess. So that would be block. Mapped. Bound expression sequence. Unexpected infix operator. Sure. That wants to be like that. think I'm going to have to do some kind of extract method on that because that is way too indented. Yeah, let's just get rid of that because we don't need it. Yep, I commented something out, didn't I? Let's try and see if we can peek it. Where would it be? Let's just do fix me. There we go. So if we get a library, what do we do? Is it even? Does it even look like that? No, it's got. I mean, really, probably should have the name. Let's go put the name on the library in the binder. This would be library. Library dot library name. Library of bound bodies. I know that's not right yet, but it will be soon. String list, bound expression list. And that should be happier. Bound expression list list. Why are you a list of lists? Hold back. That's happy. Yep, that'll do for the time being. Let's run the tests and see how broken everything is. My coffee is considerably cold. Might need to be microwaved for the third time today. Okay, so we are now binding the bodies of libraries. What have we still got to do? Let's put the to-dos in and then we can come back and implement them later. So to do here is library libctx should be seeded based on the imports. For declarations. So what we'd have to do is like loop over all of the declarations. I think we need to build up the scope first, but for binding all of these bodies. So we'd loop over the declarations, and then we do binding of the bodies. But we also need to deal with the exports. To do context should have bindings added for each export. Is that right? No. Store some reference to this library. I think once we've seen the library declaration, we can store it in the context, and then when someone does an import, you would look in that place. So just like we have an add macro on the context, binder context, where are you? So binder context, we have add macro. It's not really a scope element. You have to come up with some representation, but yeah, you'd have to store the library on the context. And then when someone does an import, you'd search through all the libraries. And to be honest, there's probably going to be a short enough number of them that we can just have a list of libraries and append to the list. And then when we want to import, just do a linear search, because fancy data structures are fancy, but often you find that just with a small enough number, looping through until you find it is actually quicker. So what have we actually done so far? We basically just reintroduced binding for libraries. That's close enough to a commit message. Libraries are bound. Libraries now contain the bound bodies of any begin forms. Still to do. Remember or store libraries in the context when declared. and support importing Okay, I think I'm going to call it a day there. So let's go over what we've done. The initial approach to libraries, we were trying to mix in the parsing or the recognizing of the structure of a library definition and declaration with actually trying to bind it. So turn it from some syntax into some strong representation where we understand what all of the symbols are that we're referencing. So we have introduced this new libraries module, which contains our types now for representing libraries. So we have a library definition, declaration, import set, export set. We've got all of the parsing code, which correctly emits errors. So we actually have this public method now, parse library definition, that returns us let's just view this properly, which returns us a result which contains our library definition and always includes some diagnostics, because we know that parsing libraries could return warnings as well as errors. And then we've changed the binder so that we call out to this method, to the parse, and then we actually do a bind as well. So in the binder, we now create a new scope, bind all the bodies of the library in that scope, and then return a bound expression, which we can use later on. The idea is that when the compiler encounters one of these, it should then go through and emit code for all of the bodies, but into a new type based on the library name. And that's it. So thanks for watching, and I will see you next time.